Okay guys, so we're going to be looking at some properties of logarithms to try to help us solve and simplify certain expressions. And the first thing we're looking at is three different properties that you'll need to know. And the first one deals with the product property. And I'm taking the log base b of a quantity x times y. And one of the things we notice when we do that, that gets me the same answer as if I were to do the log base b of x plus the log base b of y. So when I look at a logarithm and I see two things being multiplied together in that log, it is the same thing as me adding those two quantities together with the same base b. When I look at the quotient property, I'm taking the quotient of two values x and y, and me taking the quotient of two values when I take the log of it is the same thing as me finding the difference of those two things. Okay? And then the power property, it kind of is built off this idea of the product property. So just assume that I had the log base b of x squared. Well, I know that's the same thing as log base b of x times x. And using the product property, I can rewrite that as the log base b of x plus log base b of x. Well, that gets me 2 log base b of x. So what's happening is that power is going in front of the log. So what I want to do is just look at a couple examples, and you guys will try a few. And let's start with these problems right here. So we're just going to start off with some just problems in which we have some actual values associated with it. So I know that the log base 5 of 3 is approximately this number, and I know the log base 5 of 7 is approximately this one. So I want to be able to approximate what this value would be. So what I do know is that I do have the quotient property in action right here, because I do have division. I'm dividing 3 and 7 from each other. So I know it's going to be log base p, or log base 5 of 3 minus log base 5 of 7, because I know with the quotient property, when I'm dividing, that is the same thing as me subtracting the two logs of them. So I'm going to be taking 0.683 from 1.209, and I'm just finding the difference of those two quantities. And when I take the difference of those two, I end up with negative 0.526. So when I look at this, I have 21. Well, I mean, I don't have 21 up here, but I do know that 3 times 7 gets me 21. So I know it's the same thing as me saying log base 5 of 3 times 7. Now, based off the product property that I see right here, is if I'm multiplying two quantities to get that number, that is the same thing as me adding the two quantities together. So I got log base 5 of 3 plus log base 5 of 7. So all I'm going to do is add 0.683 to 1.209. And that means that the log base 5 of 21 is the same thing as 1.892. Now this last one, number 3, I see log base 5 of 49. Well, how can I get 49? I know it's the same thing as me saying log base 5 of 7 squared. All I'm doing is looking at, hey, how can I use the 3 and how can I use the 7 to get that 49 I'm looking for? Well, I have that square, so that means I can bring this 2 in front of everything. So that's the same thing as saying 2 log base 5 of 7, which is the same thing as me saying 2 times 1.209, which is equal to 2.418. Okay? So I want you guys to try examples 4, 5, and 6, and we'll talk about those tomorrow. But I do want to kind of go over some other examples of me expanding these expressions here. So I want to be able to expand this. So I have log base 2 of 7x cubed over y. The first thing I notice is that there is a quotient property going on here. There is division. So I'm going to rewrite this using the quotient property. Log base 2 of 7x cubed minus log base 2 of y. Well, once I know that, I can't really do anything more with this, log base 2 of y, because it can't be expanded anymore. So I look here, and I do see the products property going on here. So I can expand this and get log base 2 of 7 plus log base 2 of x cubed. And I still have that minus log base 2 of y. Well, I can't do anything with log base 2 of 7, but I can look at log base 2 of x cubed, and that's the power property, so I can bring the 3 in front of it. So I got 3 log base 2 of x minus the log base 2 of a y, and then I have a log base 2 of 7 in front of all this. So let's look at one more. So I look here, log base 5 of 2x to the 6th. I look, and product property is usually the last thing I worry about. I usually look for the quotient property first, and then I look for the power property. But I do see the product property involved here, because I do see multiplication. So I have log base 2 of, or log base 5 of 2 plus log base 2 of, or log base 5 of x to the 6th. The product or the power property allows me to bring in front. So I got 6 log base 5 of x plus log base 5 of 2. Try the next couple, and we'll see you tomorrow.